Whew. Okay. So, that was a lot of hard work, right? Finding 32 different combinations was a real effort. So, good for you for finding them, because that was hard stuff. That was difficult stuff. And so here, I have also found all 32 combinations that Otto Toyom can make out of his materials, out of his limited resources. 0 cars, 5 trucks, all the way down to 0 trucks. 1 car, 4 trucks, all the way down to 0 trucks. 2 cars, 4 trucks, all the way down to 0 trucks. 3 cars, 4 trucks, all the way down to 0 trucks. 4 cars, 3 trucks, all the way down to 0 trucks. 5 cars, 2 trucks, and then 1 truck, 0 trucks. 6 cars, 2 trucks, 1 truck, 0 truck. And finally, 7 cars and 0 trucks. And our assignment from the book said that after we made this list, we had to plot those points on a graph. And what I'm going to show now is exactly how to do that. I'm going to get us started with the first couple of points, and then you're going to take it from here independently on your graph paper. So let me turn this on over. Oops. To my, thank you, Desmos graph paper that I'm using here on the monitor. Excellent. And now I have myself an X and Y axis. On my X axis, I've labeled this cars. We're going to keep track of our cars on our X axis. Our trucks, we're going to keep on our Y axis. And so now is the time for you to grab your graph paper if you don't have it already. Grab a ruler if you don't have one already. And you need to recreate this first quadrant, meaning everything where X and Y are positive, on your graph paper. Start from X equals 0 and go all the way up to X equals 10. Start from Y equals 0 and go all the way up to Y equals 15. Pause the video here so you can do that. And once you come back, we're going to get into it. So we know that Otto Toyom can make 0 cars and 0 trucks, which is like obvious. He could just like do nothing with his time, right? And in that case, we mark the point 0, 0 with a dot on our graph, just like that down there. This point tells us that 0 cars and 0 trucks is a valid combination that Otto can create. But it's not the only combination. We have 31 combinations left, right? So let's look at another one. Otto can also make 0 cars and 5 trucks. And I'll mark that point right there. 0 cars, 5 trucks is where we have 0 on our x-axis, which measures cars, and 5 on the y-axis. The y-axis measures our trucks. And he can make 0 cars and 4 trucks, 0 cars and 3 trucks, 0 cars and 2 trucks, 0 cars and 1 truck. All of those combinations of toy cars and toy trucks are valid combinations that he can make with the materials that he has. And this is how we represent it on our graph. We also know that he can make 0 trucks and 7 cars. That was a valid combo that we found. And we mark it just right there. We know that he could make 3 cars and 3 trucks. And we can mark this point here, where cars is 3 and trucks is also 3. Okay. And so your task is on your graph paper, mark the remaining, let's see, 31, 30, 29, 28, 27, 26, 25, 24. Mark the remaining 24 points that are valid combinations of cars and trucks for Otto Toyom. And once you've completed that task, you'll be ready to move into the next video where we get to tell Otto how to optimize his constraints, how to make the best choice that he can with the limited resources that he has. Again, that's what constrained optimization is all about. And I can't stress this enough, you will do this in your life. If you have a good system for like turning it into a math problem, you can be very confident, entirely confident that you're going to make the best choice with your limited resources. So stay with me, stay focused. If you have questions, ask them, because I want to make sure that you can like do this when the time comes. This is very, very important. Keep marking those points, and I'll see you in the next video. Bye.